today we're going to find the displacement 4 different ways. So if you don't understand by using the position function, then I'll show you by using the area under the curve. If you don't understand area under the curve, then we're gonna use d is equal to half a t squared. If you don't understand that one, then we're gonna use the average velocity. So 4 different ways displacement. Get it started. All right, the problem said that Bari went on to a bike trip which is 1.5 hours long, and his position function is 40/3 t squared. All right, let's first do the diagram and then velocity versus time graph, and then 4 ways we're going to find the displacement. All right, 4 ways. All right, so is 3/2. How do I know 3/2 is given? 1.5 hours. D final. So now I'm going to find the total displacement. So the displacement is, I'm going to use the position function. What is the position function? Is given 40/3. 40/3 t squared. 3/2. 40/3. 3/2 squared. So that gives me 40/3. 9/4. 10. 3. So the displacement is 30. So it's 30 mile hour. All right. So the displacement is 30 mile. Now I'm going to show you 3 different ways to calculate the displacement. 3 different ways. So the first way, by area under VT graph, velocity versus time graph. So what is the initial velocity? Initial velocity is 0. Final velocity, we're going to have to use the velocity function, and the velocity function is given 80/3t. All right, so we want to find the velocity, final velocity, the velocity when the trip ends. The trip ends at 3/2. So 80/3, 3/2. So 3 cancel, 2 goes to 40, 40. So the final velocity is 40. Velocity final is 40 mile per hour. Okay, so this is 0.5, this is 1. Initial velocity is 0. And final velocity is at 1.5, the velocity is 40. So I'm going to calculate the area under the curve to find the displacement. So area under the curve, area under VT graph. So what is the area under VT graph? Half BH. And area under VT graph is the displacement. So displacement is half. What is the B? B is 3/2 or 1.5. What is the H? H is 40. 2 goes to 40 20 times, 2 goes to 20 10 times, 10 times 3 is 30. So the displacement is 30. We got it. Displacement is 30. Okay, now we're going to do a different way. This is the number 2 way, and number 3 way. We're going to use displacement is equal to average velocity times delta t. All right, so average velocity is v initial plus b final over 2 times delta t. So what is the v initial? V initial is 0. What is the v final? 40 divided by 2. What is the delta t? 1.5 or 3/2. So 40 divided by 2 is 20, 3 over 2. So 2 goes to 20 10 times. So displacement is 3 times 10, 30. So this is the third way we found the displacement. This is the first way. This is the second way. This is the third way. Now we're going to find it fourth and final way. Displacement, fourth and final way. Displacement is equal to half at squared. Now displacement is equal to half. What is the AA? Acceleration. Acceleration is given 80 over 3. And the T, 3 over 2 square. So the displacement is equal to 1 over 2, 80 over 3, 9 over 4. 3 goes to 9 3 times. 2 goes to 80, 40. 4 goes to 40 10 times. So displacement is 10 times 3, 30. Alright, so in this video I show you how to calculate the displacement 4 different ways. If you don't understand this way was I use the position function 40 over 3t squared. I put that time 1.5 and that gave me 30. This way is the geometric way. I use the displacement is, since this is a triangle, half BH, and that gave me 30. This one is the average velocity times the delta t, and that gave me 30. And this one is the kinematics formula also give you 30. So no matter what formula you use, you get the same displacement. Hopefully you understand.